Hi, welcome back to Sedan Machinery. Today we're going to talk a little bit about our line-by-line programming in our nuLINK control. So what the line-by-line programming is a very simple way to write a program. As you can see on the screen right now, we have a graphically drawn program for all those fancy people who want to do those things. But we got a few old schoolers still out there. So what we didn't do is we didn't eliminate the old school use of this control. It still exists. So let's go find it and let's learn how to use it. So we come here to our home and we see where we have line by line. We click it. Now now we have just a basic programming screen, and it has basic functions. You can create a line and assign it an angle. You can produce a hem, and you can produce radius bends. Okay, and what we have across the top here is the different columns that are going to be created as you draw your lines. All right, you can put an order number, a customer number, a note. You can tell it what width your part is going to be. You assign it the material table that you want it to be. Okay, so that'll give you your automatic angle corrections and things like that. So it's still got some advancement into it, but by and large, it programs very, very old school. So let's get started with a program. And we're not really making a program per se. We're just showing you the functions and going through the columns. All right, so start with a line. Here we go. You click that line button and it's going to produce a line for you, and you define the parameters. I'm on line 1 out of 1. And I want that to be 90 degrees, or if I want that to be a 45-degree bend, I assign it 45 degrees, right? Now I tell it where the back gauge needs to be. Let's just choose 20 inches for our sake, okay? And then how tight do I want to clamp? This is 6% clamp pressure. I can clamp it anywhere from 0%, and 0 is our baseline, so make no mistake. Even if you choose 0, 0 is enough preload pressure for you to make a bend, okay? And usually when you're running 24 gauge, you should use anywhere between, I don't know, 6% and maybe 35%, depending on what you're bending, okay? And then the next column you have here is the opening height, all right? So this opening height means how high, after I've clamped and made that bend, how high do I want that upper nose to raise up so that I can manipulate my part? If you're just advancing it forward, you can leave it at a very low value like this so that you don't get above the safety stop. But if you have to pull it out and turn it around, you can assign it a higher value, 1 inch, for example, and it'll raise up 1 inch, and so you can put the part, take it out and put it back in more easily. And this is where you choose your bending beam speed. Okay, we allow it to go up to 120% speed, which is not a problem as long as you're running thinner material. But once you get into the little bit thicker material, you're going to need to bring that down to the normal 100%, because this thing will run 100% duty cycle all the way into its highest range of material. But once you get the thinner stuff, we allow you to overspeed it just a little bit. All right, this next column here is if you have a machine with automatic material thickness adjustment. This is where you control your bend center and where you can control your bending beam depth. The model that this one is attached to does not have that feature, so this value for me in this class will be set to 0. The next thing we have here is number of plies. If you look over here, you can do up to 6 plies. So where does this come in? What this is saying to the machine is an example. I have some basic valleys or ridge cap. They don't have hems on the end. All they got is a little pitch angle in the middle, right? And I'm running 29 gauge, and I know I can stack up 3 or 4 of these things and bend them all at one time, right? And I put them in the machine and I clamp down on it. But if the machine is only expecting to see a thickness of 1 of those, and it sees 4 of these things, right? It's going to give you an alarm, say, hey, your material is too thick. So you have to come here and say, hey, machine, yes, I'm running 4 of these, right? And it'll say, oh, okay. And then it'll set that alarm to if it gets thicker than 4 of those parts, right? But keep in mind, if you're using a number, anything other than 1, you need to be mindful, just like you do in that nice fancy draw programming. And each time you alter this parameter, you need to make sure that you're operating within the capacity of the machine and you have the proper tool on for that, okay? A second way to use this is if you're making a coping, right? And you want to make a coping that has open hems on each end. And the easier bend sequence is to run these parts, to run that coping, where at the very end in your last two bends is you're having to clamp the jaws of that machine down on top of that, okay? So you may have to set that, value a little bit higher so that it doesn't give you an error. But also when you're using that, you come over here into the clamp pressure and you don't assign a percentage because it'll clamp it all the way down. You can come over here and set what we call simulated clamp pressure, right? And then I can assign a value to this at simulate clamp pressure. Right, and so now I can come here and I can assign a value, and a good normal value for that is about 0.180. Okay, and so now what will happen when you get on that line and you put that open hem in there, the jaw is going to come down and clamp to about 0.180. It's just going to be tight enough to hold it down, right? And it's going to look here and say, yep, you've told me this, but I also know this here. And it works with those two pieces together, and so that you don't get an alarm for a material being too thick. Okay. All right. Next column here is part manipulation. If you look here, part handling. Right here, there's no real known part handling. What am I doing with this? Am I flipping it? Am I spinning it? What have you? So you have all the little selections over here. I can flip it in, roll it in. I can move it 90, counter. I can do whatever I want. I'm just, for the sake of this class, I'm going to put a flip in there and I'm going to assign it. All right. So now anytime I get to this line, I'll look up here and I'll say, oh yeah, I need to flip that part. Doesn't do you much good on the first line, but it's there. All right. So here's the tooling. When you have the little dot here, that's assuming that you're using the sharp tool. Okay. But if you need to use the box tool, the box and pan tools, you click on this line and it gives you some options. You simply say rotate. That means that combi beam is going to rotate over and it's going to start using that tool. When you're running profile parts where they're 10-footers, nothing really else to do on that line except tell it you want that tool. But if you are running a complex box part, you will have set up a few tool stations here, and then you would be able to choose your station and you can apply them to different sides of the part there. But for our purposes here in this down and dirty program is we're running a box tool at full width. Okay. Now, I don't have a material set up for exactly this. So if you ever get this little red dot, you can come here and select for all missing materials, and it will present to you the material tables that you've constructed for this machine that are the closest to what you have. So here, if I'm running a 118-inch part, 111-inch width is fine enough to be able to run what I need to run. So I'll pick that material table, and it says, okay, let it fly, and it'll work just fine. All right. I also have notes. I can put whatever I want in here for notes. I can type in where's the color, because you don't have a graphic when you're in line by line, right? It's just a down and dirty old school part, but you still want to know for color up, because when you're training those new guys and you already have written all this stuff, it reduces your scrap rate. All right, so color up or color down, whatever you want to say, or you can write anything about the job that you want. Okay, and populates here, hit OK. So now every time I get to that line, it's going to display the note here. Right? And then last but not least, well, this here is just telling you that it is a basic program line. There's no really extra things to do, because everything that you need to make that simple bend is already defined in one of these columns. All right, so that's programming a simple line. Now, if I wanted to copy that down, right, I could, if I had another bend at 45 and I needed it to be at different inches, so let's say I'm moving it forward a couple of inches and now my back gauges are going to be at 18, right? there. So I can copy lines down and it will move everything with it. Okay. So now I want to start a new line with a hem. I know you normally do hems first, but I'm working these icons in their order. All right, so hem. So I'm going to add a hem. It created a new line for me and it put in all the generic information. All right. So there's no angle because it automatically assumes, if you look up here, it is automatically assuming the max angle that it can bend on that tool. All right, so you don't have to worry about assigning it a hem angle. And then you tell it where you want the back gauges. Where we want the back gauges at 17.5. Okay, and you know what? Let's not do that. We want the back gauges to be at. Let's clear that out. We're going to run an inside hem. We're going to put 0. We're going to go 0.5. We're just going to make that a 1/2 inch hem on the inside of the machine. That'll help me explain to you some of the other features. All right, as we go along. All right, so we're flipping that part around. So we kicked it out. Now what do we want to do? We want to roll it in, right? So let's come over here to where our part manipulation is, our part handling, and we're going to do it forward. We're going to roll it in, right? Right, so that's done. We're doing a clamp pressure this time. We're doing a clamp pressure this time. We're not doing anything fancy with this. And we want our clamp beam to go up at least 1 inch, right? So we can flip that part in. Right? If you can do it without that, that's not a problem. Again, we can leave the default speed in there. It's thin material. This number carries down, all right, because we don't have a machine in this setup that has that automatic movement. So this number just rides 0 all the way down the line, okay? And now we only have one part thickness put in there, right? So this number of plies stays at 1. We have already assigned our flipping. We're going to use the sharp tool. So we went back to the default tool. Now we're going to go here, select this for the missing material. I chose to do this so you guys can see that this can be done, okay? I have material tables in here that would match that number exactly, but for this exercise, I need you guys to see what can be done, okay? So I'm going to be doing this throughout this little module. All right, note, is there any note for me to put in here? Not so much. And it shows me a hem, all right? But now when I press this hem, there are a lot of things that you can do with that hem. I can control the hemming height, right? And this hem height means how tight am I smashing that hem? That's what that means, okay? The next one says open position at hem. So you know, we pre-bent that hem at 146 degrees, right? But after that bend, the upper beam has to open back up so you can slide it back in there to smash it. So this value here, right, is what you assign for that opening height, okay? And now let's jump down a little bit and I'll come back to this. This hem back gauge move. Hem back gauge move, right? Hem back gauge move is how far is those back gauges going to push that material a little bit forward or a little bit backward so I can get it inside the jaws in the right place before I do the smashing, okay? That's what this number is for. And this number, you always type it in as a positive number. The machine will decide by the type of hem that you choose, open, close, or teardrop, which direction it needs to move, and that'll be automatic. So if you choose an open or a closed hem, it will automatically push the back gauges back so that it goes more into the machine. If you choose a teardrop, it will push it outward, okay? Now we have this nice little feature called finger protect, right? Everybody knows that when you're smashing a hem, right, that wherever the bend line was and you go to smash that hem, that material wants to slide towards the bend line, okay, towards wherever the bend line is in the material. So if you're doing an inside hem like what I program, it's going to want to slide backwards into the machine. And if I were doing it with the small flange sticking out, it would want to slide outward into the machine, okay? But this finger protect is more specifically designed when you do an inside hem like what I have programmed. All right. So what will happen is when you come down to clamp the material, that material naturally wants to walk backwards. But what's sitting back there? The back gauges, right? What you don't want is that material sliding back and pushing up against your back gauges and scratching your material. Okay. So when we select an inside hem, we can select finger protect. And when the upper jaw comes down, the upper beam comes down, and it makes contact with that material and it's holding it at right around the safety stop opening height, right? When it reaches that point, then the fingers automatically back up about 1/4 inch. So they get out of the way. And then the machine does the final clamp. That way, when it clamps, it's not rubbing that material up against those back gauges, okay? So you typically don't use finger protect when you're doing an outside hem, but it is a very nice tool to have when you're doing an inside hem. If you're running material that has film on it, you probably won't use it at all. But if you're running raw edge metal, then you'll probably use that quite often. All right. So we have another feature in the hem, and this comes in handy when you're making some pretty complex parts, and you got to pre-bend that hem, but you can't smash it yet because you got to go do some other things in that part, and then you can come back and smash the hem later, right? Well, we can go ahead and program all that now. So you hit this thing called splitted hem, all right, and hit OK, and it produces me a second line. But look at my hem symbols; they changed. Okay, this one is now only the things it takes to make the bend for the hem, and this line here, right? This line here can be moved anywhere in the program except for in front of the bending line, okay? So if you have 5 more lines before you want to smash that hem, you can move this down. So you come here, you assign it an angle of 0 because you're not going to be bending it again, okay? And you tell the back gauges where you want them to be. I'm going to tell them I want them to be at 0.5 because I got pretty much a 1/2 inch hem anyway on the inside of the machine. And this is the clamp pressure. This is the open height afterwards. We don't need to know the bending beam speed again right now because it's not going to be using the bending beam. It's just going to be smashing, right? And again, the material thickness adjustment is not automatic on this machine. We're only really caring about one ply. It doesn't really pay that much attention to this when it knows it's smashing a hem, okay? And was there a part manipulation for this? If there was, let's just say it was this, right? Can't be 90 degrees, 180 degrees or more. Oh, we're going to flip it this way. Okay. All right. All right. If we're going to smash the hem, same tool, material table at this point doesn't really matter because you're not bending anything because material table has angle compensations. When you're smashing a hem, angle compensations don't really mean anything to you, so they are just not populated. If you wanted a note to put in here, if you needed to put a note in here, obviously you could type a note, all right, and you could say whatever you wanted. I don't know, turnover. Whatever you wanted to write, okay, save it. Right, and that kind of concludes us with the things you can do with the hem. The next function is radius bends. All right, if you select this icon, you do a radius bend. So it's going to be a 0 degree angle because it's going to get that number from a different place. Okay, you tell it where you want your back gauges to go. We want them to start at 12. We're going to use 6% clamp pressure, and our opening height is going to be 0.230, right? Just below the safety stop so that you don't have to raise that thing up, down so much when you're doing this. The bending speed can stay 120, can stay 12 if you want, it doesn't matter. And again, you don't have a movable bend center on this machine, so this is at 0. We're doing 1 ply. Let's just say we didn't have to, yeah, well, we did. We flipped this over. Okay, and we're using the standard tool. And now we're going to go to the material table. and we're going to do all missing and go here. Okay. Now it's assigning that value for us. And now we get to the radius bin. So once we click this icon, right, the machine has already defaulted to a few things because we know when we're doing a radius, we need to know a couple of things. We need to know what angle do we want that radius to finish at. We need to know what is the radius, and we need to know the number of steps we want to do. And from those three things, we can get the other two. Okay. And a lot of people ask me, why can't I just tell it the step length that I want in the middle and tell it the radius and tell it the angle? Well, you can do that, right? If you're doing math on paper. But what's going to happen is you may pick a number here that says, okay, I need 90 degrees, I need 2-inch radius, and I use this number of steps, but it's going to come out and say, hey, you need 23.8 steps. You can't do 23.8 steps. You can do 23 or you can do 24, but you can't do an 0.8 of a step. So we let it automatically default to 25 steps, a radius value, and an angle, a finish angle. And from there, we can control these other two values. Okay. So the machine has what we call granularity. You get 4 choices. You can set it on fine. You notice how it increased the number of steps. It reduced the step length. It reduced the step angle. You can put it on medium. You can put it on coarse. By the way, it defaults to medium. You can put it on coarse and it changes these things, right? Or if you just want to define it yourself, you could come in here and type in a number 30, 35, and you can get it to manipulate these two numbers to whatever you want. Okay, cool. All right, so that's the way to control it. If I change the radius, let's just make it 2 inches because it's an easier number to look at. Okay, 2 inches, it changed these numbers, all right? So everybody knows that if I bend at 2.6 degrees, right, I'm gonna get a lot of spring back, right? So I need to be able to add some angle correction. But I can't add it here because if I change this value, it'll mess up the whole formula calculation. So what we have here is a compensation column, right? Where it will add angle correction in the background without affecting our formula. So let's just say I need 5 degrees. So what's going to happen when I set up for this, it's going to take that 2.6 degree, which is my theoretical and my expected result. It's going to add 5 degrees to it. So I'm going to actually bend to 7.6 degrees. Okay. So now we're ready to go start bending. We can choose bump bending or we can choose wing bending. Okay. And if you have more than one radius within your program, you don't have to bump bend both of them. If one of them you want to bump bend and the next one you want to wing bend, well, you can do that as well simply by clicking that button, and it will automatically change that process for you. All right. It doesn't program any different. It just makes the machine sequence differently when it starts to run. So bump bending, what does bump bending do? Bump bending means that it's going to come down and clamp the clamping beam. It's going to raise the bending beam and at this number plus this number, and it's going to sit there static. And then it's going to open the upper beam. And when you hold your foot on the left pedal, it's going to continue to cycle. Clamping beam down, clamping beam up. It will advance the back gauges by this value, and it'll start that process, and it's going to do that 35 times. So it's going to incrementally bump your radius. Okay. Now, wing bending. Wing bending does essentially the same thing, except it doesn't just set that bending beam static. It sits back home at 0 like a normal bend, and it will clamp, bend, raise up, advance the back gauge, clamp, bend, and it will do that 35 times. So now, and do I use the difference between the two? Okay. Bump bending is when you're using lighter gauge material and you want some accuracy, but it's good. Let it fly. Okay. Wing bending is when you really want that extra accuracy. Okay. And you're doing some with thicker material. Okay. Because it's clamping and bending, or every time like a regular bend. So this is when you use the different once, right? And you hit OK, and it applies it. If you want to copy another line, you can copy them, right? Or if I wanted to take line 5 here and I wanted to move that up in the sequence, see this arrow here? I can move that without having to rewrite that whole line. If I wanted to move it down, I can move it down. Or if I simply wanted to trash can that line, I can trash can that line. So hopefully this was helpful for you to see a simple way to program it, what I would call old school. We didn't forget the people who really like to use old school. You know, technology is really advanced these days, but sometimes people just want a little simplicity. We have simplicity in our control. Hopefully you enjoyed this and have a nice day.